Alright. So, if you remember, that's integration with anti-derivatives.
No, I don't.
No.
So, you should remember your derivatives of inverse trig functions. So, you will have to be able to identify the antiderivative for inverse trig functions. And yes, it just requires straight memorization. There's no way around that. So, again, if you have also the C and cosecant, which was integral 1 over I want to say it's x squared plus 1 dx is secant x plus c. The inverse of -1 over f divided by x squared of x plus 1.
For the inverse trig functions, their co-functions are just negative.
Yes. No. It's been a while since I've done these.
No.
Yeah, there's our cotangent as well. That's just
It was Alexu.
for this rest of this unit, yeah. A little bit of chapter 7, a little bit of chapter 8 is Cal 1, but yeah, we're delving more into the actual Cal 2 stuff. But it's been a while since I've done these. Okay. And so did anybody have a question on this right here?
No.
Okay, because I do.
Oh, it's a question.
Then me too.
My question is, we could factor out a negative for that bottom one for cosine, right? Our cosine. Couldn't we factor a negative and say that it's negative arc sine?
No.
I'm gonna turn this again.
Couldn't we do that?
No.
Oh, it's the
No.
It's been a while since I've done it, so.
Wait, you actually genuinely don't know?
No.
Oh.
It's been a while since I've done it.
Trying to get us to get to the right answer.
I know.
I think we have somebody who's been teaching calculus for a lot longer than I have. Studying for several. No, he wouldn't know this.
Should we ask him? Should we take notes?
But I'll ask him and we'll find out. So there's somebody studying for Bevel who's
No, please don't ask him that. Will it?
No, yeah, well,
Oh, I love him
Yes,
so
He's
much.
dying.
My mom was sad I didn't have him.
I know.
No.
that's okay.
I finally.
She had him in high
Okay.
school. No.
I'd like.
No, she had him in high school. That's
Yeah. But he retired, so.
Yeah.
Now he retired partially because they were trying to force everybody to do CPM, but encouraged his retirement.
CPM.
You don't know CPM? You guys had to do CPM, didn't you?
No.
All the time.
It's, where'd you guys, you guys didn't take out 1 here, did you? Then yeah, you wouldn't know it.
Well, this.
It was a mess, that's what it was.
Oh.
Basically, CPM was student-based inquiry and learning.
I feel like the flip classroom thing.
No, it's worse.
Oh.
Yeah. Because the teacher doesn't teach anything.
What happened?
The students follow a story in their book to guide them through the lesson.
Wait, in which class?
And my job is to facilitate their learning by walking around and make sure they're actually doing the work. And if they're stuck on these things, I ask engaging questions. The problem with that is students don't want to work.
Yeah.
Now, honor students, that would kind of be okay.
Not really, because I like do
But the problem with that is, with the honor students, is that the homework didn't match the lessons. And they got frustrated and they would stop doing anything too, because they found no point in it. Because literally the homework did not match the lesson.
If it doesn't match, then why do it?
It was driving me crazy when I first got here.
Wait, which class was this?
When I first got here, I had to teach it with geometry.
Ooh,
Oh.
do they still do?
No. After a month, I stopped doing it. I was supposed to keep doing it, but I just couldn't because after one lesson, I couldn't tell you what they were even supposed to learn. Not if they learned anything, but what they were even supposed to learn. I was like, I'm confused by this. And I'm the teacher. Okay? The students are just, they're done. I had a student crying because she's like, I have no clue what's going on in this class. I'm failing.
That's me, but she's not great.
Yeah. So I was like, that right there, like, I'm done with this. And do you guys remember Miss Martin?
Yeah.
So I kind of went to her and she said, you know, do this, we're doing something else, just don't tell these people. So we actually had two different math departments my first year here. One math department encouraging CPM and another math department just subverting it as much as they could. Actually, you know, teaching. And yeah, it was real fun.
Make it hard.
Real fun. My first year. After that though, whenever all the people who were trying to enforce CPM left, everything was fine. It was like, we got rid of it. Just we're done. Okay. So it was much better. You could see the difference in our EOC scores before and after CPM. So, oh, yeah. It was real fun along the way. But anyway, they were trying to force that all the way up through, like all the way up to calculus.
There's
They are really going to. And actually, one of the assistant principals at the time was, I don't know, he wasn't here. When I got here. Yeah, they was
retroactively. What was your first year?
2 years ago.
It's probably Do you remember that whole verse? There's like a picture of him with a shine. Yeah.
I was here after a lot of things that happened here happened. Okay. I was made here.
You have a ball better than me.
Yeah, I heard. That was my first year. I think he was here for a little bit. What? This is my third time.
Yeah.
This is my third teaching here.
Speed was legal.
Teaching other
I
people.
know, but I thought technically fired of it, but they said that he was not fit for a student environment, and then
Put him as a better name.
more fit for a student environment because he related to it.
So does that tell me how much weed you smoke, right?
Well,
I'm glad I'm recording this, but
you're not because they're not published on here.
I just haven't published them.
Oh.
Should probably by the time the day ends, I'm like, I'm done. I'm tired.
You should probably send this to Candace.
Yeah.
I think she's
Alright,
Anyway.
so looking at example 1 here, we have the integral of 1 over 9 plus x squared. The idea here is if the function has some way of looking like
What's our?
the inverse trig functions, then we are going to use some method in which we can factor out to make it into an inverse trig function. In this case, one of the big things here is we have to have 1 plus x squared, so 1 plus some function squared. Okay, so how do I make that a 1 instead of a 9 in the denominator? Divide and factor out of 1/9. So we're going to get 1/9 integrals. Okay. Now, if we divide everything by 9, that's going to give us 1 over x squared to the 9, which you want to write as a function squared. Okay. So x squared to the 9 can be written as x over 3 squared. And now we have our format that is our inverse trig function. Okay. But we have to do this with substitution. Because then we have, anytime we have a chain, anytime we have a function inside a function, in order to do an inverse chain rule, we do inverse chain through substitution. So here we're going to substitute u in for x plus x over 3. du is equal to 1/3. Do we have a 1/3? Not quite, we have a 1/9. Okay, but that just gives you 1/3 times 1/3. Integral of 1 over plus x over 3 squared dx.
Why can't we just do one?
Well, since du is 1/3 dx, we want to replace 1/3 dx with du.
So then there's still one third.
Yeah,
Why?
we're still left with a 1/3 here.
Oh wait, never mind.
So we're still left with 1/3 there, and now we just have some simple functions. This is 1/3 inverse tangent of u plus c, and then just gives you 1/3 inverse tangent of x over 3 plus c. It's usually easier if we do an actual full example instead of what just got walked through us for us.
Oh, I have to. I can go out. You will. What is that? What's on this?
So we only have one example here, which is lava. Let's try with this. Now, what inverse trig function does this look like?
The one arc sine.
Arc sine. Okay, there's no negative up top. Okay, so we have arc sine. Now, arc sine, we have what? We need the square root of 1 plus some function squared. That's what we want to have. So, we need to factor out what?
It's mine. Can you scroll up?
Plus minus. It's the square root.
Oh, okay.
So, what are we going to factor out? 4. Because we need to factor out the square root of 16. So we're going to factor out 4. 1 over 4 times 1 minus x over square root of 16.
Huh?
Back.
About that 4.
Let's do this a little one step at a time.
Yes, please. Wait, now what do you, wait, pause.
Pause. Wouldn't you have to? Oh wait. Over. Okay. Yeah.
Try the square root of 16. What's the square root of 16? 4. I'm going to write x squared over 16 as a function being squared. So that means we are going to take the integral. Well, we can bring up 1/4 here. 1 over the square root of 1 minus x over 4 squared dx.
So, is this like where you're gonna want to bring that out like you had to yesterday with the?
I have to really bring it all the way outside, but might as well. So once we have it set like that, what do we do? Use substitution. U is x over 4, which means du is 1/4 dx. So we have a 1/4 dx, so we're good.
Wait.
We have a
Oh,
1/4
it's just 1/4 arc sine to the x over 4 plus c.
So we're square root of 1 minus u squared du.
What?
What do we replace?
U x over.
At 4th u, right? And we got rid of the 1/4 dx, replace that with du.
Oh. I didn't see this.
Do we have to do that part or can we just like no?
Okay, I have to do it.
Like you have to write that out.
Yes. So I know what you do.
Oh.
Yeah.
You can't just plug it in.
No, I need to know that what you're doing.
Oh, okay.
So, what is the antiderivative of this? Sine arc sine, you can write inverse sine of u plus c, which then we do the substitution back in. For sine of x 4. So 4 plus e plus.
It's so real.
That.
Science, I don't know what's going on. What were you?
Wait, so where did our 1/4 come from? Which was?
We got rid of the 1/4 px. Replace it with e. Oh, so we have to define.
I have a couple jokes now. I did. Well, I did this before I made it from fast. Just I
I
don't
don't know that Steve.
I was one for the rest.
Take e rated.
She does.
Oh.
I don't know. I cannot. Yeah, it was.
That's the one, but not all of us, and just like one person.
So she chooses the names. But like that applies even though it's out the most.
So you have to bring all the way outside, but you can.
Like that's what it's trying to
So because it's not constructed.
Because she was canceled. Oh, that took me.
Yeah.
Yeah. And that's this. I like, okay, so my engaged writing just.
It depends on who it is.
So those.
So we're done?
No, we have to be too.
I'm gonna swear.
No, throw.
So find the general antiderivative for 1 over x squared plus 6x plus 25.
Well,
So if you could factor this, then you would probably want to do what we did yesterday, which is solving by partial fractions. But can you factor that? No, there's no factor 25 to give you 6. So what we're going to do instead is we are going to complete the square. And the reason why we're going to complete the square, I'll find out too. So if you remember complete the square, we first get rid of the constant or put the constant outside parentheses. So we have x squared plus 6x plus blank. All right. Plus 25 minus blank. Now, the only reason I put the blanks in is because we need to add the value that completes the square. And can I just add a value?
no,
No, you have to subtract it to balance that out.
Square.
So it would be 9, yeah. Because again, if you remember complete the square, c is equal to b over 2 squared. In this case, it's 6 divided by 2 squared, so 9.
Wait, is that plus 25 minus 9?
You can add 9 in here, and to balance it out, you subtract 9 outside. Because really, I didn't
Yeah,
change
Is
you.
that on the other side of the?
There's an equal sign.
Why not?
Because I don't have them.
What does it say? 1 over 2 to
But
the
in
value
value
complete the square. It's the same thing. So if you did the other side, it'd be negative 25 plus 9.
Yes.
And
2 ways you can complete the square. One way is with an equal sign, where you can bring anything that's not the perfect square over the other side. The other way, since we're not trying to solve for x, I'm just trying to factor x, there's no equal sign, so you have to balance by just doing a plus and minus on the same side.
what is C? What is
C is b over 2. Yeah, c is b over 2 squared. So this is your b, this is your c, this is your a. Remember a, b, c, all those fun things. So 6 over 2 squared is 9. Alright. Now, the reason why we do that is what is x squared plus 6x plus 9 factored down to? So x plus 3 squared plus 14. And there I have completed my square.
You mean 60?
16. We'll go with 16 instead.
It is.
Because the correct answer is 16.
Wait. Oh.
Wait a second. Do we have a tornado?
No. No. I don't know.
He's gaslighting.
Didn't we have a fire? Yeah, we don't have a sort of. We have one tornado drill each quarter, each semester. We've already had ours. Sort of. I missed it. That's a shame. We had one. I had setting also one this semester. We don't have a lot of earthquake drills or tornado drills.
We have a lot of fire drills.
But have a lot of fire drills. So.
Especially when it's 15 degrees outside, my favorite.
Yeah, why didn't they do Wednesday when it was like 50?
Because they changed it 2 months ago. Alright. Now, since I have a function squared plus 16 in my denominator, this somewhat represents an inverse trig function,
No.
arctangent.
No.
But in order to get arctangent, what do I have to have? I have a plus 1. Does it So since I now have this in my denominator, to get a plus 1, I need to factor out a 1 over 16. Okay, so we put a 1 over 16 outside the interval. We have 1 over, and I can write this as x plus 3 over 4 squared plus 1. And dividing this by 16, that's what we get. So now we have a inverse trig. Inverse tangent. But in order to solve for this, we do our substitution method. U is equal to x plus 3 over 4, which means du is equal to what?
4 over x plus 3.
1/4 dx. If it's easier, you can write this as u is equal to x over 4 plus 3 over 4. And what's the derivative of that? Well, that's gone.
Oh.
So 1/4 dx. Now I have a 1/16, so we are going to take out a 1/4 from there. So we can now write 1/4 integral of 1 over u squared plus 1 du, which gives us 1/4 inverse tangent of u plus c. And since u is x plus 3 over 4, final answer is 1/4 inverse tangent of x plus 3 over 4 plus c. But again, this is all written for you, so you don't have to write any of that down.
So for this one, it says that.
Okay, is that when you, okay, so when you did the 1/4 dx, you divided the 1/16 by 1?
Yeah.
And you multiplied it?
Well, you multiply by 4.
Oh, okay.
Yeah.
Would dx not equal 4
Sorry, what? Yes, I what?
or d?
I mean, yeah.
But would you not put in?
Well, 4 times 1/16 is 1/4.
Oh,
So yeah, there's two ways you could do that. You could just factor out a 1/4 from 1/16 and do 1/4 times 1/4 and get rid of the 1/4. One of the 1/4s is dx. Or you could say, well, since du is this, we will have a 1/4, so we can multiply by 4. All right, and then replace dx with 4 du, which would still give you 1/4. So 2 ways to do it. Either way is fine. All right. Let's practice this. This looks fun. Now, obviously, because it's inside squared, and the nice part is here, because it's inside squared, I don't have some function outside. I'm not going to be really doing any of the inverse secant and cosecant stuff. Okay, it's either going to be inverse tangent, inverse sine, inverse cosine. In this case, since I have positive, it's going to be inverse sine. So, what is my perfect square here? Here we factor out a -1, because you cannot have any leading coefficient with this other than just positive 1 when you with the square. So anytime you have any coefficient, you need to factor out that coefficient. In this case, factor out the -1, which gives you positive x squared and positive. So yeah, plus 9, which means I'm going to add 9 here, and then I'm going to subtract. Well, technically I'm going to add 9 here as well, right? Because I have a -9 inside. Yeah, that's fun.
So 9 minus x squared plus 6x plus 9. Well, like the x squared stuff's in the.
Yeah. So because I have the 7 and the 9, the 7 from here, 7 plus 9 is
OMG.
Did you not like
This is
16 minus. X squared, well, x plus 3, right? Now, again, why did I add 9 inside and outside instead of subtracting 9 outside?
Negative.
Yeah, the negative in front of the parentheses means technically I subtracted 9 inside. Alright, so to balance that out, I have to add 9 outside. If it makes things easier, you could factor out a -1 after you put the value there. But will that make things any easier? It's really up to you in that case. So we have inside our square root, we have the integral of 1 over square root of,
When you factor out, would you put a -1/16 on the outside? Or no?
so we have 16 minus x plus 3 squared, right? Which is what we want to have inside of our, we want to have a 1, but we want to have a 1 minus the function squared, right?
Yeah, so it would be 1 minus, oh wait, so it would
Or,
be
So we're going to factor out a square root of 16. Factor out a square root of 16. So
4.
integral of 1 over square root of 16 times the square root of 1 minus x plus 3 over 4 squared, which is again, yeah, a 4. You can bring that out. 1/4 integral of 1 over square root 1 minus x plus 3 over 4 squared. Yes. So substitute that. So since we know u is equal to x plus 3 over 4, we know du is equal to 1/4 dx. And we have 1/4 dx. So this just becomes u squared. So the antiderivative is inverse sine of u plus c.
What happens? Just
Which gives you inverse sine of x plus 3 over 4 plus c.
the one that was cancel out.
We replace the 1/4 dx with u.
How is you like the x plus 3 doesn't matter and the like that? Oh, what's your
Parenthesis 4 plus 3 over 4. When we take the derivative, what happens to the previous?
okay.
You guys want to try the next one on your own?
On my
No?
I'll do number 2 by myself, but I'm not doing number 3 by myself. Well, actually,
Yeah. Number 3, just factor out 3 first.
well, but the 2 on top.
Well,
2 in front.
Yeah. So
Oh,
if you put 2/3 outside, we get 1 over x squared.
I'll do
plus
number 3,
2x.
not number 2.
What's wrong with number 2? Just factor out a 1/3. Yeah,
No, it looks scary.
it's just easier. It ends up being easier.
Whatever, I'm already doing that. Wait. I tried. No, you don't get it. Remember that's what we learned yesterday.
You will.
Is
Yeah, I'm moving this page. So ask you what method would you use to
I can do that. Yesterday?
Well, sometimes, you just have to choose what method you use, you actually don't have to do the integration. On the next page.
Yeah, I don't get it.
Wait, I get it. Hold on, don't do the
We're
answer.
just pay zero. I'm gonna just pay right. I don't get it. Cause there's like two factors, so like what do you do when there's
What can't, like which one are you doing?
three?
Because there's a two.
Three, can't factor x plus two, x squared plus two x plus five.
Oh, right. So,
Oh.
so replace what, but 7 would be 0.
Yeah. Okay,
So then all you do
that
is
one.
the middle, which is
I
2
have to put it back to 6 and I have to take
Everywhere.
It's one.
For which one?
For number three.
Yeah.
I finished my
Because you have to, well, you add one and subtract one, so you take out one, four.
Oh, subtract.
Yeah. No. And mine relearn how to complete square. I never understood that topic.
The difference between the square that you used to do is you had something like x squared plus 8x plus 17 is equal to 0 or something like that.
Yeah, and you move the 17 over.
Yeah, you moved it over. In this case, we don't have that.
Oh.
So you can't move it over, you just exclude it. You just put parentheses and exclude the 17 outside.
Oh, okay. So I got 1/2 du and I had a coefficient of 1/6. So what do I multiply?
Well, yeah, if you take out 1/2 and 1/6, what do you get?
Negative.
Not take out, but like divide.
Oh. You do not get 1. 1/3. Yeah. I didn't say 1. Right there. So that's. Yeah. 1/1.
Yeah, sorry, plus eight.
That's me. It's a. No.
So which one? I get the x squared plus eight x.
It's just a lot.
I got the men squared. Is it
That's
fast?
an example.
Oh, yeah, that was just, of how you used to do the square. Usually, you're used to having an equal sign. In this case, you don't.
Have you done? Yeah.
So is the answer 1/3 tan to the negative 1 x1 over x plus 1 over 2 plus t?
Yes.
Oh my god, guys. It works.
So let's look at number 2. For number 2, first things first, we're going to factor out that 1/3. So 1/3 integral of 1 over. Now, inside my square roots, I'm going to write this as negative parentheses x squared minus 2x, right? Plus some value minus some value.
Shoot.
Right, actually plus some value, right?
Wait, why are you doing that all in?
Because it's all inside the square root.
Isn't that just?
Yeah.
Crazy.
What completes the square there?
4.
What?
What do you be?
Gosh, never mind.
Wouldn't you be minusing it inside the parentheses?
Oh, it's so embarrassing, Chloe. Are you embarrassed? I'm not.
So again, because I have a negative outside the parentheses, to balance that plus or minus a positive 1, I have to add 1 outside as well.
Wait, is that x squared minus 2x?
Yes.
Why not?
I have negative 1.
X minus 1 squared.
Wait, third row.
What does because this is going to be sine, inverse sine, right? What does inverse sine look like inside the square root? 1 minus x squared. So I'm going to put this 1 out front.
Yeah.
Minus x plus 1 squared.
Okay.
Yes. Do I have to factor anything out? Nice. I don't have to factor anything out. I have a 1 minus. That's exactly what I need. So I can just go ahead and do my substitution. U is equal to x plus 1, which means du is equal to dx. So we get 1/3 integral of 1 over square root of 1 minus u squared du.
Oh, 2x, 3x squared.
Any questions on that?
So is this,
Oh, you divided everything by 3? Yeah. And third. Yeah, 5, that's why I had to try mine. Sine. Plus 5.
Arc sine, arc sine, you can inverse sine, sine of -1, I don't care how you do it, I'm gonna do both, just to get us, make sure we're okay with it.
So we want
Of u plus c, right?
212, so 1 to
Which is 1/3
minus.
arc sine of
4.
x plus 1.
If I can do this, are you gonna want to see the step on the test that is like the y and u? If
Not really,
Yeah,
if you skip it, it's fine.
If I put it in my, like if I did it in the equation,
Yeah,
if I label what u and du is.
yeah, if I need to see this,
Cause I.
Okay. I need to see that, but from here, you don't have to do this step, that's not serious.
Okay.
No, I can help.
I'm just putting it on there so we're comfortable.
And you already got the.
But yeah, what I do need to see is pretty much almost everything else.
Okay.
Now, do you want to walk us through number 3?
Do I?
Yeah.
Oh, okay. Yeah, I mean, so what I did, I just took the 2/3 out of the front,
right here.
and so then it was 1 over
So obviously
x
4 divided
squared
by 4
plus
is 1.
2x plus 5
And you're
dx.
doing x plus 3 squared.
And
so
then
5
I
divided by
completed the
4.
square for that. So it ended up being 2/3, the little s thingy,
Oh,
and
sorry,
then 1
mine.
over x
Because I
plus
did
1
X
squared plus 4. And then I
X plus
took
1 and
Before you go on,
squared.
before you go on, let's make sure
Divided by 4.
x squared plus 2x plus blank plus 5
To change
or
it.
plus 1 minus 1. We had to subtract 1 here
Why is it being squared?
because it's a balance out.
Plus 1.
Now, the thing that gets confusing, and I will agree it does kind of get confusing, is in the last one we added 1 both inside and outside, right? On number 3, we added 1 inside and added 1 outside.
It's because of the negatives.
Because we had a negative right outside the parentheses. So technically, this right here is a -1 because we have a negative here. So to balance that -1 out, we had to add 1 outside as well. This one is much more straightforward. We don't have a negative outside the parentheses. So to balance it out, we have a +1 and a -1. So that's what gives us this factors 2x plus 1 squared, and this gives a +4. All right, keep going.
And then, so I ended up with the 2/3 as 1 over x plus 1 squared plus 4. And then I had to take out a 1/4. So 2/3 times 1/4 is 1/6. And then it's 1 over, and it's like x plus 1 over 2 squared plus 1. And then I like labeled my variables. So u is x plus 1 over 2. And du is 1/2 the x. And then I plugged all that in, so 1/6 divided by 1/2 is 1/3. And then it's 1/3, and then it's 1 over u squared plus 1. So that's an inverse tan. So then it's like 1/3 tan to the -1, x plus 1 over 2 plus c. Just right here. It's for 1/3. By 1/2.
How did you use 1/6 to 1/3?
You divided by 1/2. Because you did 1/2.
For here, we have to take, 1/6 divided by 1/2 gives me 1/3.
It just takes a second to like slow down. Like,
Fractions, it's the fractions is what gives me.
The fractions is what got me, 'cause that's all I was asking.
I'm not good at
You could have
fractions. You're really bad at
said,
I can't factor.
I can't.
Not that big, but like.
It's horrible. I use the calculator every time.
You use a calculator to factor.
I can't factor.
If I'm like really stuck, I'll look up factors of a number on the internet.
Do that on the computer.
But like I usually can figure it out. Like it It's very rare that I have to do that.
It's not like the
It should
simple ones where it's like X squared and have the thing.
Give you the numbers. Factors of C give you B.
I know, but sometimes I can't remember all the factors of like numbers that are pretty high, like in the 100.
Yeah, in those cases, it takes more work. Then you look at C and you kind of see, again, is it positive or negative? All right, factors the same side or not, and it tells you how far apart the numbers need to be. So there's lots of cues that give you there.
Yeah.
I can understand, if you get really large numbers, yeah, it gets kind of tedious. But, yeah. Most of the factors.
Like I factors of this equation, I look up factors of C, and then I'll like add them together myself. Are we doing this whole page? Oh,
No, well, yes and no.
no. Not right now.
We're not actually going to solve it.
Oh.
The directions say just identify the method for how you would solve it.
What about the Rodriguez volume?
So now, since the denominator here is in two-factor form, we can solve this using partial fractions.
What about the 3x on the hospital still?
Fine.
Could we just put it out front?
Yeah, just means we do the partial fractions, that's our numerator, so we set 3x equal to whatever a times x minus 5 and b times x plus 1. So we set that equal, and then we plug in a minus 1 and plug in a positive 5 and see what a can be. Alright, now, for number 2 here, the second one, the second one, since we don't have any separate fractions, division.
And we did that yesterday, and no.
Or, now for the third one, this one's a little tricky. It's not factorable, and we can't do division. Why can't we do division?
Because it's x squared plus 1.
The degree of the denominator is bigger.
Yeah.
You can't do division.
Um,
Well, you can do part of the fraction because it's not factorable.
isn't that just
And
arctan?
what does arctan have in the numerator?
A 1?
A 1. We don't have a 1.
Oh, so can we divide, or should we take?
If it was 3, we could factor out 3. That would be fine. That's a 3x. So the tricky part of that is this is just
Square, or wait,
use substitution.
I forgot how to do that one, not one.
What have you been doing? Just u is equal to this, du is equal to this. In this case, in this case, we saw this, u would equal x squared plus 1, and du would equal 2x plus 1. We don't have a 2x, but just 2x dx. So we would say 1/2 du is equal to dx, and you would write this. Okay.
So then you would do like 3x over 2u.
Yeah, so you get rid of the x.
Well, oh, yeah.
Okay, you would give her the x, but you have 3 over 2 outside integral of 1 over u. du, which is natural log.
Oh, yeah. And then it would just be.
Yeah,
3
we
over
didn't even have to solve it. Yeah, but that's the set, so there we go. So you want to go ahead and solve it, go right ahead. Now, number, there's no numbers with these, so this next one, can you factor that? If you can factor that, you want to use partial fractions.
Yes. X plus 3x minus.
Partial fractions. Okay. Can you factor the next one?
No.
No. But since we don't have an x at top, we can use our arctan and complete the square.
You can't.
Actually, we already
You
have
can't
this.
complete, yeah, the square already.
The square's already completed. So yeah, just arctan it. Just factor out a 9, a 1/9. Or really, just a 1/3.
1/3, yeah.
Now, for the next one, we will want to do complete the square. And then followed by arctan. What do you think about this one?
Oh, look at this. Partial fraction.
Yeah, that's it. Use substitution.
That's not partial fraction, but I say yes.
I heard somebody say use substitution right here. So Use substitution. You don't, again, you only want to use partial fractions when you can do what? When you can factor the denominator. If you can factor the denominator, use partial fractions.
No, you
That
can't.
was good. That was.
Wait, is this like if you put like sign of something over it, it equals 1? I don't. But I feel like I saw a thing it's like if you put like sign or like it's some trig function.
Yeah. Sine of A over A is,
But there's the 2, so
that's,
that. Oh, and this is the derivative. Well, yeah, but like what we have here.
yes, sir. So now for this one, since I don't have a weird function up top, can I just divide every term by x to the 1/3? Yeah, so just, we'll call it single term division. Alright, now this is set up as what? Our side.
We don't even need to complete the square, right?
Just factor out a 49 or one side. Actually, they would cancel each other out.
So then it would just be
Well, you would have to factor out the 49 from the square root, so you
so
would
it
have to
would be
do
1 over
x
1 minus x over 49 x over 7 squared.
So it would just be arc sine of x over 7 plus c.
It's just, it's not.
Right. Now again, we have something I can do division with, so that is your division. Whether long division or synthetic, that's no different.
And then this is
On the test, do you have like a section that says like specifically use one of the two?
I have yet to make it. So it's sad.
Well, I think we should not.
So
I think we should do is just
Again,
synthetic. Oh, no.
I'm trying to figure out how I'm gonna do this test, because I'm
like that.
gonna have like an A-B version of this test and a B-C version of the test.
Open it.
So what we did the first half of this was A-B, and then everything since partial fractions.
Is that why
BC.
there's 2 parts?
Yeah,
Okay.
mainly because there's way too much to put on one day.
Yeah. Can we use a calculator on both parts?
I don't have sex.
I don't even know like what I would use a calculator.
Yeah, I don't know what you use. For the first part, I don't know what you calculator.
A comfort calculator. I literally, if I have a calculator, I would put 9
could use it, right?
That's sad to the test, and you have to factor it out.
I mean, I'm not factoring, I'm adding.
It's not that I can't factor, it's that I can't do it like with like 3x squared plus 7x plus 5.
Well, that's when you have to make the annual box.
The AC method.
I forgot how to do box.
You have to do the X and then you make the box and then.
Thinking about it.
So,
Is this one complete the screen?
Jen, do you get, not show this to you, but give me a second. We have, let's say, 3x plus 2 and x minus 5. Let's say we have this multiply together, 3x squared minus 13x plus 5. Okay? So if you factor this, there is, I don't know if you've seen this, but I learned this while I was working at Giddings. You can do what's called the AC method. You multiply A times C, which gives you negative. Factors of negative 30 give you negative 13 would be.
Yeah, I know, I did. That's the only way I know how to factor. Yeah. I know.
Wait, I'm not done.
That's fine.
Okay, so you have negative 15 and positive 2. Factors of negative 30, they give you negative 15. X minus
It was primary?
15,
That was the only way.
x plus 2.
Sorry, yeah.
Oh, I always thought you were supposed to make the box.
Yeah.
Shortcut to this. We did A times C, right?
Yeah.
Balance that out, we're gonna divide by
Yes.
3, divide by 3, so we get x minus 3. Now, since this doesn't divide,
You do.
anything in the bottom is gonna move up front. 3x plus 2.
Wait, let me see. I learned that like algebra 2 and everything was going on.
Yeah.
I
So that is the easy way to factor when you have any.
just
I'm not teaching what we're looking for.
I know you've been doing APC. Oh,
Like, oh, we can.
oh, it hasn't been the last notes you did with the second derivative. That's all that's on Canvas.
Yeah.
Okay.
We use that. We have forgot. As before that.
Okay, that's fine.
What page notes of that is?
You have videos, the last one posted is the second one.
Hold on for you. This,
Yeah, just give your.
No, that's where
This-
I start. I haven't done this yet.
okay. Like,
Over at Algebra 1. I missed challenge.
No, in the video ended
Um,
with this.
those
Those were days.
Days of
Okay.
because we've done.
being able to have fun.
We have done.
What's this? 2 of them.
Okay, that's fine. Thank you.
A 3
Blue.
Okay.
Alright.
It doesn't make sense. Just
I ever stopped that recording? I never did.